Good morning, grade 5s, and welcome back. This is Unit 6, Lesson 4. We're going to be looking at one last attribute of quadrilaterals, which is symmetry. And I'll sum up a couple of the things we talked about last week, because this is the last the last lesson that talks about quadrilaterals. After that, we're going to be moving into three-dimensional shapes. So you should be familiar with these 6 shapes we talked about before. We've got our square, a rectangle, our trapezoid, and we have our rhombus down here, which is just our leaning square, our leaning rectangle, the parallelogram, and our kite. All of them have slightly different attributes, but they have one thing in common. They all have 4 sides. They're all 4-sided shapes, and that's what makes them a trapezoid. So let's take a look at a couple things we did last week with these shapes. The first thing we did was we marked the sides that are the same length. So if we start on the square, squares have 4 sides that are the same length. So we can mark that with our hatch marks here like so. Each one of these lines represent the fact that the length is the same. We've got 4 equal lines, 4 sides that are the same on the square. On the rectangle, it's going to start out fairly similar. The top and the bottom you can see are the same length, and the sides are the same length. So I'm going to mark it like this, and I pointed out last week that this is not correct anymore because it's denoting that the top and the side are the same length, and that's not true. So what we need to do is we need to put a double hatch mark on either the top or the side, and it's kind of like just saying these two are the same, but they're not the same as the side and the top. Okay, so that's how we would mark the rectangle. When we move on to our trapezoid here, the top and the bottom are no longer the same length. The sides on this trapezoid are the same length. So we could actually mark them if we wanted to, like so. However, a trapezoid, if you remember, only has, well, it has one defining characteristic, and that's that the top and the bottom are parallel. And you can see that they are parallel with each other, but the sides aren't always going to be the same length. Let's take a look. I have another one underneath here. This trapezoid here actually has a right angle on the top and the side. These two are still parallel, so it's still a trapezoid. These two are not parallel, otherwise it might have been a rectangle. But we don't have these two lengths being the same anymore. They're not the same length. The top and bottom length aren't the same. In fact, no lengths are the same, and yet it's still a trapezoid. So we can't say that all trapezoids have the same length on the side, but it can happen. Hopefully that made sense. Let's move on. The rhombus down here is the same thing as the square. It's got 4 sides that are all the same length. All that we changed were the angles, and that will affect us in a little bit here. So we can actually just go like this, and boom, all 4 sides are the same. Same thing with our parallelogram. We've got our top and the bottom that are the same, and we've got our sides that are the same, just like we had on the rectangle. The diamond doesn't have as much shared attributes with the trapezoid. I just put them together because those were our last 2. The diamond is actually kind of unique. It has sides that are the same length, but they're not opposite each other. They're actually adjacent to each other, which means that they're next to each other. So if you look here, the top part of sorry, I think I called it a diamond. The top part of the kite has 2 sides that are the same length, and the bottom part of the kite has 2 sides that are the same length. Just give me a second here. Okay, kind of messy hatch marks there, but this is the defining feature of a kite. The bottom 2 sides have to be the same length, and the top 2 sides have to be the same length. I mean, you could turn your kite sideways and then it'd be left and right, but the sides that are the same length need to be next to each other, and you'll notice that every other shape we had, they were across from each other, with the exception of maybe the square and the rhombus, because all the sides are the same length. So, kind of a trick question for you. Is a square a kite? What do you think? It is. Technically, a square and a rhombus are examples of kites because they follow that one rule where these 2 sides are the same and these 2 sides are the same. So, the more you know. One of the questions in your workbook for Unit 4, or sorry, I keep saying unit, for Lesson 4 was, why is a rectangle not a kite? So I'm going to give you an answer because you watched this far in the video. Why is a rectangle not a kite? Because the adjacent sides are not the same length. You'll notice that this side and this side are not the same length. So you could write something like that, and that would be perfect. Let's move on to marking our parallel sides. So we use this little arrow marker to mark our parallel sides. Our square has 2 sets of parallel sides. Like, what am I doing? The top and the bottom are parallel. And the side, ooh. And the sides are parallel. But of course, the side is not parallel with the top. In fact, on a square, those two sides are perpendicular, which we'll talk about in a second. But for now, let's just mark our parallel. So our square has two sets of parallel sides. That's what we say, the top and the bottom, and the side and the side. Same thing with the rectangle. The rectangle has the top and the bottom being parallel, and it also has the side and the side being parallel, like so. Well, actually both of our trapezoids, let's take a look at both of them. The top and the bottom of our trapezoid, ooh. The top and the bottom are parallel, like so. Sorry, rectangle. And same thing on our other trapezoid. Now, does that have to be the case? Well, no, but remember our trapezoid definition was that it needs to have one set of parallel sides and no more. So technically, we could rotate our trapezoid like this, and now the top and the bottom aren't parallel, but our sides are parallel with each other. So it's still a trapezoid. We just rotated it. Does that all make sense? Let's move on. So our rhombus here is going to have four sides of parallel sides, just like our square did. In fact, we can just copy them over, and they should fit pretty nicely. So it's maybe a little bit off. And same thing with our, wow, blank there, parallelogram. Okay, and now that I'm doing this, I'm actually just noticing that I made a little mistake. I don't know if anybody caught it. Same thing with our hatch marks. I don't want to say that this side is parallel to this side, and so what do I do here for my marker? I wonder if anybody caught it earlier in the video. If so, good for you. I need to double these up. Same thing I did with my hatch marks. Okay, like so. Just to show that those two sides are not parallel with the top sides, even though it should be pretty obvious, that's how you would mark it. You've got the double arrows on one side and the single arrows on the other side. Okay, the last shape we have here, and we've made a bit of a mess with our parallel line markers, is our kite. Our kite has sometimes parallel sides, but in this case, this side and this side aren't quite parallel. They're not quite in perfect line with each other. And these two sides are not quite in perfect line, so this kite has no parallel sides. Can a kite have parallel sides? Well, yes. As we talked about, a square is a kite, and so is a rhombus. And so if you drew a kite with all four sides the same length, it would have some parallel sides. But as soon as these bottom sides are different length than the top sides, we won't have any parallel sides. That's just how it's going to work. So in this case, we don't get any parallel markers for our kite. Let's move on to the last thing we learned last week, which was about our perpendicular sides and our right angles. So if two sides are perpendicular to each other, this is the opposite of parallel, it means that they join at exactly an L shape. Now, usually, or at least last week, I would mark that by drawing, kind of completing the square in the corner, like this. But I'm going to show you something else we can do here. I'm going to take this square, any corner on any of these shapes that this square will fit in perfectly is 90 degrees. Because we know squares are have 90-degree corners, I can put this into any corner that is 90 degrees. So you can see that a square has four 90-degree corners because the square fits in each corner. Same thing with a rectangle. It's going to have four 90-degree corners. Let's take a look at our trapezoid here. And remember, we have two of them. The secret trapezoid. Okay, let's take a look at our trapezoid. The bottom one here, I just said bottom. The top one here has actually two perpendicular sides, or right angles. However, the bottom one, if I try and put my square into the corner, this is what I mean by not fitting. Look, you either have a little bit extra here, or you have not quite enough, and it comes outside the shape. You can't actually fit the square neatly into the corner. So none of these sides are right angles. Let's take a look at our rhombus here. Can I put this into any of the corners? No, 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 no. None of these are right angles. Same thing with a parallelogram. You won't be able to fit this square into any of the corners. And let's take a look at our kite. There's something interesting here. obviously, just by looking at it, I can't quite fit it in, but you might think, well, what if I rotated the square a little bit so that it fit in nicer? Now, sometimes, some shapes you might be able to rotate and get a square to fit in here, but in this case, notice the bottom's lined up and the side isn't. This square still won't fit in. Let's check the top here. And it's going to be kind of close on the top, but this is still not a right angle. It just isn't. Now, again, to look at it, the best thing you can do, in my opinion, is to say, do any of these shapes form an L? Now, that's not how I would draw an L. It's more like a greater than sign. Same thing with this angle right here. That's not an L either. It's a little bit bigger or obtuse. And so, no, none of the shapes, or no, sorry, none of the angles on this kite are right angles. So there are no perpendicular sides. So just to recap, which of these shapes had perpendicular sides? The square, the rectangle, and one of our trapezoids. But none of these shapes on the bottom had any perpendicular sides in this example. Now, that was all review. Let's take a look at the one last thing we're talking about, which is symmetry. So you guys probably know what it means for a shape to be symmetrical. A symmetrical shape is a mirror image from one side to the other. So if you put a mirror right in the middle of the shape, looking into the mirror would complete the shape. So I'm going to use this dotted line to represent my symmetry line. A square has a symmetry line right down the middle. As you can see, everything on this side is mirrored on the other side. Okay? How many symmetry lines can you make on a square? What do you think? Giving you a moment to try and figure it out. Well, obviously I've got my one up and down. I can also put one right down the middle. Sorry, a horizontal symmetry line. There's two more. You can actually make a symmetry line right through the corners of a square, because this triangle here is inverted and flipped to make the other triangle. And of course, I can do that in the opposite direction too. I can go like this. So a square actually has 1, 2, 3, 4 lines of symmetry, or what they're called. Now, you would think maybe the rectangle would be the same, but it is not. We've got our vertical line of symmetry, which is true. This rectangle, if I put it right in the middle, this rectangle would be the same as this rectangle. We've got our horizontal line of symmetry. However, the corners do not form lines of symmetry on a rectangle. Now, at first glance, it maybe looks like they do, but if this was a true line of symmetry, then this triangle here would have to be reflected onto the other side, so the point would actually be somewhere up here. I want you to try this for yourself. If you can't see it right now, I want you to draw a rectangle at home, and then take a mirror and put the mirror right on the corners and see what shape it makes when it reflects. It won't be a rectangle, but it might be a shape that you recognize here, okay? Let's move on here. The trapezoid has sometimes a vertical line of symmetry, and that is it. But if we look at our second trapezoid here, our hidden one, it no longer has the vertical line of symmetry. So trapezoids often won't have any symmetry at all. Okay, that's obviously not symmetrical either. And so we have no symmetry on that one, and just a little bit of symmetry on this one. A little bit of symmetry. One line of symmetry is the correct way to say it on this one. Okay, what about our rhombus though? Our rhombus has, does it have a line of symmetry? It does actually. The rhombus has a line of symmetry through the corners. You can see that both sides reflect each other. However, if you try to line up a vertical line of symmetry, you're not going to be able to. It's close, but this side and this side are not equal to each other. You can see one way to test a line of symmetry is to measure off of the line in both directions. So if you measure from here to here, this distance is actually shorter than from here to here, so it's not symmetrical. So again, the rhombus only has 2 lines of symmetry. Like there to there, and there to there. Good. What about a parallelogram? It's going to be actually no lines of symmetry, because again, our corners are not a perfect mirror image. Otherwise, this would have to remember, you can measure off the mirror. If I measure straight down from here, and then straight out from here, well, really it should be over here, but straight out to here, you see that this line is much longer than this line, so it's not symmetrical. So the parallelogram, in this case, has no lines of symmetry. Our kite, as you can see, has one line of symmetry right down the middle, which will always be the case. And it's tempting to maybe try and put another one right here, but that will only work if these all four sides are the same length, like in a square or rhombus. In this case, this is not symmetrical because this is not as long as this. Remember, measuring from this side and measuring from that side. Okay, that was a lot. However, I imagine most of you guys are already comfortable with symmetry, so you're like, why are you talking about this, Mr. Shell? Just needed to review it. So now we can try this exercise here. So I've got a bunch of shapes. I added a couple more to the ones we had before, some wonky looking ones. And this here is our Venn diagram. I put some different labels than the one in your workbook, but we can try a couple here. So I want to sort these shapes, either put them in this circle, or in between the two circles if both of these labels apply. So let's take a look at our square. Has at least one line of symmetry. We know squares have 4 lines of symmetry, so it's going to go somewhere in this circle. Does it have at least 2 right angles? Oh, of course, it's got 4 right angles, so it's going to have to go right in between these two. That makes sense? That's how we're going to continue to sort these. I'm going to give you guys a second to try this on your own. You can pause the video, and then I'm going to start sorting them pretty quickly. Awkward silence. Okay, hopefully you tried it on your own. If you're just sitting there watching the video, maybe you didn't, but that's okay, you can do it with me. So, looking at a rhombus, does it have at least one line of symmetry? Yes, we just talked about that. It's got 2 right from the corners, so it's going to go somewhere in the circle as well. Does it have at least 2 right angles? Now, a rhombus doesn't have any right angles. Remember, the square didn't fit in any corners, so it's going to go in this circle, but not in the center. We can put it over here somewhere. I'm going to continue to sort these. Does our parallelogram have at least one line of symmetry? No, it does not. Does it have at least 2 right angles? No, it does not. Now, in a Venn diagram, if it doesn't fit in this circle and it doesn't fit in this circle, it actually has to go outside the Venn diagram. So I'm going to put it over here for now. I didn't really think this through, but it doesn't have either of those, and that sometimes happens in a Venn diagram. We're going to put it over here. Okay, does this trapezoid have at least one line of symmetry? Well, this one does. Looks like right up and down the middle. Does it have at least 2 right angles? No, doesn't have any. Let's put it over here. This kite has a line of symmetry and no right angles. It's going to go over here too. I'm going to guess that this is going to be very populated, this area over here. Has a line of symmetry, yes. Has at least 2 right angles. Put one over here. Haven't seen anything over here yet. Does this weird shape have a line of symmetry? Let's make it a little bit larger, just so we can see. I don't think so. Can't divide it down right here because it's got that little cutout here. Nope, no lines of symmetry. Does it have at least 2 right angles? Yeah, there's one right there, and there's one up here. Right there is a bad pun. So let's put it over here. What about this wonky shape? This is kind of, looks like it's trying to be a kite, but it's not. It's actually just a trapezoid that's been turned a little bit. See? That should look a little bit more familiar. So, oops, I think I just changed the proportions. Does it have a line of symmetry? No. Does it have at least 2 right angles? Close, but I'm going to say no. So it's going to go over here with our blue friend. Okay. Oops. Apologies. I think I just messed up my screen size. Yep. Well, I'll just bring these guys back into view. Okay. What about this light green shape over here? To make it a little bit bigger. Does it have a line of symmetry? No, no, no. I don't think you could draw a line here to make this symmetrical. Does it have at least 2 right angles? No. It's going over here as well. Let's make it smaller again. Okay, this kite-looking thing does it have a line of symmetry. Looks like right down the middle. Actually, I don't know if this, well, it is a kite still, but it looks like it has 2 lines of symmetry almost. Maybe not quite, but I would say, right here is a line of symmetry. At least I tried to draw it, so it was. So, has a line of symmetry. Does it have any right angles? Let's take a look at our square here. See if we can fit it into one of these. Not quite. So, no, doesn't have anything. It looks like a lot of my wonky shapes but we're ending outside of my Venn diagram on this case. And finally, does this have a line of symmetry? No, it does not. It looks tempting to try and split it right down the middle, but it would actually not reflect. If you put a mirror there, it wouldn't reflect properly. Does it have at least 2 right angles? It doesn't have any. It's over here as well. What a boring Venn diagram. Let's move on to the next one. Okay, how we're going to sort the shapes this time, we are going to, let me just try and fix this before I move on. I wonder what that's going to do. Okay, we've got our shapes, same shapes, but different Venn diagram. Which shapes have a pair of parallel sides and which shapes are not symmetrical? Okay, so square has a pair of parallel sides, yes. Is not symmetrical, no, so it's got to go over here. Does it have parallel sides? Yes. Not symmetrical? No, so it goes over here. Not symmetrical, meaning it has 0 lines of symmetry, and we're going to see a couple of those in our wonky shapes. Okay, has a pair of parallel sides? Well, I would think that a parallelogram has a pair of whoa, that's a tongue twister, but you know what I was trying to say. So yes, is not symmetrical. Yes. Remember we talked about the parallelogram has no lines of symmetry, so we can put it right in the middle. Our trapezoid here has parallel sides, top and bottom, and it looks like it is symmetrical, so we'll put it over here. Our kite has a pair of parallel sides. No, it does not. Remember, sometimes kites do, but only if all 4 sides are the same length. Is not symmetrical. Actually, it is symmetrical. So it doesn't fit in here, doesn't fit in here, kite's going over there. Pair of parallel, yes. Not symmetrical. No, it is symmetrical, so it's going to go over here. No parallel sides, and it is not symmetrical, so we can go over here. Ooh, we got one in this circle now. That's great. Actually, we went in that circle last time too. Just a coincidence. Okay, does it have a pair of parallel sides? It does not. It's very close, but I don't think that the top and the bottom are parallel, which means that I think I called it a trapezoid last time. It's not a trapezoid. What would this thing be? It's just a quadrilateral. It's not quite a trapezoid. It's not a kite, not a parallelogram, not a rhombus, not a rectangle, not a square. It's just a thing, just a wonky shape. Anyways, it's not symmetrical, has no parallel sides, so it can go over here with the red shape. This one, not symmetrical, no parallel sides. This one, no parallel sides. Well, it's very close to parallel. I'm going to say not quite. Well, let's call those parallel. So it has parallel sides, and it is symmetrical, so it's going over here. And finally, looks like some parallel sides, and no symmetry. Not symmetrical, so it's going to go in the middle. Okay, hopefully that helped you understand how we can sort our shapes using Venn diagrams. You did have a question on that in your workbook. And that's pretty much it for this lesson. I know it got kind of lengthy. If you watched to the very end, kudos to you. If you didn't, that's probably because you didn't need to watch this far because you already understood what you were doing. Anyways, have a great day, grade 5s.